Now let's discuss example 14. Before I start, I can from part A we stop y equal ex, and now how can we find the inverse function of this? If it is y equal x over 2 divided by 2, we know that this is simply make y minus 2x over 2, then 2 times y minus 2 equal x, then x become y become x. That's how we find inverse function. So likewise, how can we find inverse function of this one? To find the inverse function of this one, we need to take, so you want to make x as a subject. To make x as a subject, what we can do, the standard process, we are going to take ln from both sides, then ln y equal, this x is become ln e. Then ln e is 1. So ln y equal x. I will rewrite this one, x is ln y. I change. Now x become y become x. So x instead of I put y, and this is ln x. So this is the, if fx is ex, if this is the function, the inverse function is ln x. And here you know that ln is 1 because ln equal log e to e base. So then x ln e, so x log e base to the e, so e base to the e is 1, that's why ln e 1. So question example 14, we have to find the inverse function. X domain is given all the real numbers, minus infinity to plus infinity, but we can't put x equal 1 because when x equal 1, this is going to be asymptotic. Now to find the inverse function, okay, I will write this is 3 over x minus 1. Then I want to make x as a subject. Now I'll bring x minus 1 up, and I'll bring y down. So x minus 1 equal 3 over y. So x equal minus 1 to other side, 3 over y plus 1. So then we have to change x to y, y to x. So then y equal 3 over x plus 1. So if inverse x, this is the inverse function of this one, plus 1. Now the domain is x, element of real numbers, but x equal 1, and this is fx, and we want to find the range. Now when we look at this one, so I'm not going to find the range. Instead of that, I can look at the if inverse function domain. What is the domain of if inverse function? Now we can put anything, any real numbers, but I can't put x equals 0. If I put x equals 0 here, 3 over 0 is going to be infinity, so that is not a acceptable answer. Infinity is not an answer. Hence, I can put any value to here without x equals 0. Then x belongs to real numbers, but I can't put x equal 0. So I can't put x equals 0. Now you can see that this is the domain of fx and this is the range of fx. So domain of fx, range of fx, and this is become domain of f inverse x and range of f inverse x. Domain, this is range of fx and this is domain of f inverse x. So both are same. So instead of looking for range, I just look at the inverse function domain. When I look at domain, I can see I can't put uh, I can put any value except x equals 0. Example number 15. Now when you look at this one, we need to find the range and inverse function and the. Now if you look at when you see a square root, always the message is whatever inside it should be greater than or equal to 0. So this value x minus 2 has to be greater than or equal to 0 because square root cannot be negative. As a result, x, when we solve this one, x is greater than or equal to 2. That's why domain is mentioning that x equal greater than equal to 2. Right? So then you have to put x values and the minimum value you can put 2. And when you put 2, your y value should be 0. Yes, 2 minus 2 zeros. Then any value 3. When you put 3, 3 minus 2, 1. If you put 4 or any value 2.1 and in between any value, so you will get that decimal values, and likewise you can put any values greater than 2, then you will get all the values greater than 0. The graph is something like that. All the values greater than 0. Graph is something like this. And x value, this is x equal to, we discussed in the previous session this one. And then the y value is, this is when it's go to infinity, this will go to infinity. So this is the y range. So minimum is 0, maximum is infinity. Now the range is going to be y greater than or equal to 0, or you can write fx is greater than or equal to 0. Now we want to find the inverse function, part B. So I will write this one, y equal x minus 2. Then I'll square this one, both sides, to get rid of, I want to make x as a subject, so I want to uh, void this square root, get rid of. So y square equal x minus 2. I will rewrite x minus 2 equal y square, a equal b, b equal a. Then x equal y square plus 2 minus 2 to other side. Then x to y, y to x to y, y to x. So this is y equal x square plus 2. So f inverse x is x square plus 2. So this is the inverse function. And we need to write the domain and the range. Now x minus 2, x is the element of R, x greater than or equal to 2. So this is fx, and we get fx greater than or equal to 0. Now if inverse x, so what is the domain now? Domain is fx greater than 0, greater than or equal to 0. Range is um, x is a real number, and this is y belongs to, or fx is a real number, and fx greater than 0. So x greater than or equal to, uh, so since it is range, so I'm going to use y values. I will revert this one, we'll forget this one, this side, and then we have to write in terms of x here. um, X is a real number, x greater than or equal to 0, this become y, because uh, y greater than or equal to 2. I rewrote this one if you're confused, so I can avoid that. Now f inverse x function, so this is fx, x, this is the domain, and this is the range, and I wrote inverse function now. Now this is the domain, so the arrow is this side both now. Then this range become domain, so instead of y we have to write now x element of R, and then x greater than or equal to 0. Now domain range of this one is going to be the domain, and now we need to write the range. So instead of range is, this is the answer. So instead of x we want to write y element of R, and instead of x we write y greater than or equal to 2. Now we need to sketch. This is the y equal x line, 45 degrees one, and this is the graph fx starting from x equal to, then the mirror reflection uh, of this one, 90 degrees line. That's how usually, so this is this point, this distance and this distance should be same. So this is, it should be equal from here to here, here to here. So likewise, when you draw, this is x equal to, then this is has to be 2 if it is the same scale. So y equal to, example 16, the first we need to find the inverse function. So y equal x square minus 3, and then we have to make x as a subject. So I will write x square minus 3 equal y. So x square equal y plus 3, x equal square root um, y plus 3. We know that all x value is greater than 0. So then we have, there is no minus 2 square like that. So only positive values. And now we have to change x to y, y to x. So y equal x plus 3. And we know that the square root this value has to be greater than or equal to 0, because as I said earlier, negative square root is not defined. um, and mean x greater than or equal to -3. Now I have fx function. X is belongs to real numbers, but x has to be greater than or equal to 0. And f inverse x, this is the domain and this is the range. Now I can see that, so this is f inverse x, x plus 3. So domain has to be greater than or equal to -3. X greater than or equal to -3. And x greater than or equal to -3. Now I know the domain of f inverse x. So this is should be the range of fx. So instead of x I write y real numbers, y greater than or equal to -3. Range of f inverse x is this one. So instead of x, y relevant, y greater than or equal to 0. We will sketch now. This y equal x square minus 3. So you know y equal x square graph, something like that. Then y equal x square minus 3 mean you have to bring down the graph like this. Then this is x element of real numbers, and now real numbers and x greater than or equal to 0. In that case, what will happen? It's going to be the positive x values, the graph is. Then so half of the quadratic graph is going like this, and this is the mirror reflection. If I keep y equal x on a mirror, so it should be the mirror reflection. This distance -3, then this distance also should be -3, and something like this. And the last part, we need to solve two equations, y equal x square minus 3 and y equal square root x plus 3. And so we have only one intersection point. So when we equal fx equal f inverse x, fx is x square minus 3 equal square root x plus 3. Now we can see that. So this is going to be a difficult equation to solve. Still we can solve this one. Rather than that, when you look at, we can see that this is this equation is to get this intersection point. We know that y equal x line also going through this point. So rather than we need to find the x value, instead of that we can solve fx equal x, or in terms of y we have this equation y equal x square minus 3, that one, and we have this equation y equal x. So x square minus 3 equal x, and x square minus x minus 3 equal x. Then this is a quadratic equation. So when you solve this equation using the quadratic equation, you'll get two answers. Out of that, we only select the positive one because we have the answer is in the positive area, and 1 plus square root 13 over 2. So this is the answer is going to be, this is the x value, 1 plus square root 13 over